We all think, constantly, but have you ever really stopped to wonder what a thought is? And I don't mean in a philosophical sense. I mean, what is it physically? What is literally happening inside your skull when an idea just pops into your head? For centuries, that was a complete and total mystery.
So yeah, let's start right there with that huge question. What exactly is a thought? A spark? Some kind of chemical reaction? For the longest time, the mind was treated like a black box. We could see what went in and what came out, but what happened on the inside? That was pure guesswork. Today, we're going to pry that box open and see what modern science has actually found.
And to really get where we are now, we first have to understand the old way of thinking, this idea of the ghost in the machine. So early pioneers in neuroscience, guys like Broca and Wernicke, they made these incredible discoveries linking things like speech to very specific areas of the brain. And this led to a really intuitive idea that the brain was basically a map, a spot for everything. A spot for memory, a spot for language, a spot for logic. And hey, it made sense. But it turns out that's just a tiny, tiny piece of the real story. And that brings us to what is probably the single biggest revolution in how we understand the brain, this huge shift from thinking about spots to thinking about networks. Okay, so this is the crucial point. The old view saw the brain like a filing cabinet, right? Information and different functions were all neatly stored away in their own separate drawers. But the new view, it sees the brain as this incredibly dynamic social network. A thought isn't in one spot. It emerges from this constant, high-speed conversation that's happening between many different parts of the brain all at once. It's not about the spots. It's all about the connections. So who are the key players in this massive network? Well, think of it like an all-star team. You've got the prefrontal cortex up front, kind of like the project manager, handling all the planning. Then you've got a region for directing your attention, another for managing your whole library of memories, and a system that brings in emotion and motivation. The key thing here? None of them work alone. Thinking is a team sport happening inside your head. So what happens when a really critical hub in this network, let's call it the brain's control tower, suddenly goes offline? Well, that brings us to the absolutely wild and famous case of Phineas Gage. Back in 1848, Gage was a railway foreman. He survived this horrific accident where an iron rod shot straight through his head, and it specifically destroyed a huge chunk of his prefrontal cortex. Yep, that SOM planning and decision-making hub we just talked about. Miraculously, he survived, but he was never, ever the same person again. The details of his case are what's so mind-blowing. See, before the accident, Gage was known as this responsible, well-liked guy. Afterwards, he couldn't stick to a plan to save his life. He became super impulsive, and his social judgment just vanished. His friends famously said he was no longer Gage. He had physically lost the part of his brain's network that managed his ability to control himself. Today, scientists call these abilities executive functions. You can think of them as the brain's CEO, or maybe its air traffic controller. They're what let you plan for the future, hold information in your mind, and stop yourself from doing something impulsive. Gage's story was really the first dramatic clue that the CEO wasn't some abstract idea. It was a physical part of the brain's network, right there in the prefrontal cortex. So, okay, the brain is a network. But for a long, long time, we all believed it was a network with fixed wiring. That belief, though, was about to be completely shattered, revealing a brain that is constantly changing. The next massive breakthrough was this idea of neuroplasticity. The old belief was, basically, that once you hit your early 20s, your brain structure was set in stone, done. But now we know the brain is plastic, meaning it physically changes and rewires itself your entire life based on what you do and what you experience. It's incredible. And this isn't just some theory. We can actually see it happening. Learning something new physically strengthens the connections between your neurons. And check out these examples. MRI scans show that professional musicians literally have larger areas of their brain devoted to controlling their fingers. And people who read Braille, they develop larger brain regions dedicated to processing the sense of touch. Your experiences are quite literally sculpting your brain. So how in the world did we figure all this stuff out? How did this idea of thinking become something physical we could study? The answer, in a word, is technology. The scientific revolution we've been talking about wasn't just about new ideas. It was driven by the invention of these amazing new tools that let us peer inside a living, working brain for the very first time. These are the tools that finally opened that black box. Things like fMRI let us watch blood flow in the brain, so we can literally see which networks light up when you're, say, solving a math problem. An EEG can track the timing of a thought down to the millisecond. We can even record the firing of a single neuron now. These tools are what turned thinking from a philosophical concept into a physical process we can actually see and measure. And it all leads to this one huge takeaway, which is summed up perfectly right here. Thinking, reasoning, planning, all that stuff we do, it's not some abstract mind stuff. It's not a ghost in the machine. It's the direct result of dynamic physical processes that are happening inside the vast, interconnected network of your brain. So, if we know that science has proven our experiences are constantly and physically rewiring our brains, well, that leaves us with a pretty profound question, doesn't it? Knowing all of this, what are you going to choose to experience next?